So welcome to Pure Math 030. This is a lesson, a trigonometry lesson on general solutions. So recent lessons have been dealing with radian measure and how we can solve all the regular problems of trig using rads instead of degrees. And this is an extension of it, just a special topic that you'll see throughout the rest of the unit. And it's called general solutions. And general solutions are when you're solving questions looking for angles, such as this one. But instead of being given a specific domain that is between 0 and 2 pi, or 0 degrees and 360 degrees, it's left open-ended. Now usually the questions would tell you to find a general solution. But it's based on the idea of coterminal angles. So let's launch right into it. For this first question, 2 sine theta plus 1 equal to 0, I'm going to get a general solution for it after I solve it, and I'm going to express that in degrees, not in rads, and I'll do one of each. This is actually a trig equation, even though it wasn't formally called that, because it's not given to us as a ratio. We are looking for an angle, but we have to isolate the sine theta first. So you do a little bit of algebra. And I'm not going to show these steps because it's a fairly simple one, but you bring the 1 over by subtraction and then divide by 2. So sine theta is equal to -1/2. And I really want to reinforce the idea when you're solving these little trig equations, or when you're given a ratio and you're looking for an angle, you do this 3-step method. You identify the quadrants. Where is this going to be? And because sine is negative, we know we're going to be in 3 and 4. So you really have to force yourself to get good at that. So you don't have to think too hard about it. Sine is negative in quadrants 3 and 4. And by using your calculator, and I didn't show this step again because we've done it a few times, and you also want to be really clear and good on this. When you're looking for an angle, or specifically a reference angle, you go second function sine, or whichever trig ratio, 1 divided by 2. Do not key in the negative, remember, because the negative is there just to tell us where we're at, and we want the reference angle, and we don't want our calculator to get confused about where we're going to be. If you put in negative, it'll probably give you -30 for an answer, and we don't want that. So ignore the negative. And once you get that reference angle, and you know you're going to be in quadrants 3 and 4, you simply put that angle there and go after the principal or the regular rotation angles. So if you have a 30-degree angle in quadrant 3, it would mean the rotation angle would be 180 degrees plus 30, and then which is 210. And then in quadrant 4, it would be 360 minus 30. So remember that the reference angle is always off the x-axis. And now we get our two rotation, our two principal angles. Normally, that would be it if the question had said find an answer between 0 and 360 degrees. However, we wanted a general solution. And the whole idea about the general solution is that with coterminal angles, you can keep looping around in both directions and you end up at the same place. So if you keep adding on 360 or subtracting 360 or multiples of 360, like 720 or whatever, in other words, keep doing many, many, many loops, you have this family of coterminal angles. And with the general solution, we indicate that, or we, explain the existence of these. So this general solution, you can see the 210-degree angle is just the first rotation, but if you did another loop around, another 360, you get another one. And so the way I'm going to write that is I take the principal, or the rotation angle, theta is equal to 210, the smallest positive one, and I go plus 360 degrees n. Now you've seen this a little bit earlier in one of the other lessons, but by going 360 n, where n is an integer, like a counting number plus or minus, we're getting multiples of 360, because that just means that the base angle is 210, and you're adding on, 360. You're adding on 360 times 2, 720. You're subtracting 360, in other words, going 360 times n equal -1. But it's always multiples of 360, and you're covered. You now have a general solution that shows anybody who's looking at this answer that 210-degree answer keeps recurring every 360 degrees. When we start graphing these, you'll also see another application of this idea. But from here on in, you've got to keep your eyes open if they ask for a general solution. And we have to do the same thing now for 360. So we start off with 330, excuse me, and I'll go straight to the answer. We take 330 degrees plus 360n, and that means multiples of 360 as long as we indicate that n is an integer. We can't do like rational numbers or something for that because it has to be a no fractions. In order to be multiples, n would have to be 1, 2, 3, etc., or negative 1, 2, 3, etc. Sometimes people will use whole numbers, and that's okay too, as long as they go plus or minus. And it doesn't matter what letter you use, N, K, M, lots of them. Let's try another one, but this time let's do it in rads. And this is going to force us to raise the level of our game a bit. We start off with another equation. So I'm throwing in equations instead of ratios, but do not be alarmed because with a couple quick algebraic steps, you've got them where you want them. We are dealing with a reciprocal function, that is cotangent. But again, don't worry about it too much. Simplify it. So cotangent squared theta. Remember the exponents are tucked in. This is the same thing as cotangent theta in brackets all squared equal to 1. We don't want square. So we take the square root of both sides and we get cotangent theta is equal to plus or minus 1. Keeping in mind when you take the square root, you need to go plus or minus. And here we note that cotangent is the reciprocal of tan. So if cotangent is 1 over 1, then tan is also 1 over 1. The reciprocal of 1 is just 1. But we need it in that form because if we're going to use our calculator, we have to have it in the primary forms. So I'm going to do the same thing I did before. I'll identify the quadrants. We've seen this earlier, though. When we have plus or minus, tan is positive in 2 quadrants, tan is negative in the other 2 quadrants. So really, we are in all quadrants. So that's good and that's bad. You don't have to make any hard decisions, but it also means more work because instead of getting 2 answers, we're going to get 4. And our reference angle, if you use your calculator, second tan in degrees, 1, you'll get 45 degrees. Now, if you were in rad mode, and some of you would have instinctively done that when you see the question in rads, we run into a limitation of the calculator. If you keyed that in, second tan 1 in rads, it's going to give you a decimal answer. And it cannot handle the exact value that pi over 4. So there's a way to get around this when we look at special angles, because ultimately you're going to memorize that that's 45 degrees, or that pi over 4 is the same as 45. But the way I did this one is I used it and kept it in degree mode, and I got 45 degrees, and then I converted to rads. And as you recall from the previous lesson, it is possible to do everything in degrees and then convert to rads at the end, but you are making a little bit of work for yourself because it is, you're doing all these extra conversions. So what I'm going to do with this question is I'm going to keep degrees and rads kind of running simultaneously. I want my answer in rads, but just to give me a frame of reference, I will keep it in degrees for the time being. Eventually you wean yourself off that, though. Anyways, enough talk. We take a look at that 45 degree angle, or that pi over 4 rad angle in all 4 quadrants off the x-axis, and this is what it's going to look like. And then I'm going to get the 4 answers in rads. Now the quadrant 1 solution is just going to be 45 degrees, or pi over 4. But in quadrant 2, it's a little more work. So there's our pi over 4 in quadrant 1. Pi over 2, in quadrant 2, a reference angle of 45 degrees will give you a rotation angle of 135 degrees. So you can either convert that 135 degrees into rads, or you can just recognize now, I've seen that one a few times now. I know that that is 3 pi over 4, and you'd be correct. Anything with a 45 degree reference angle is going to be a multiple of pi over 4 in rads. So therefore the same thinking would be in quadrant 3. That pi over 4 reference angle in quadrant 3 will produce a rotation angle of 5 pi over 4. So it's really just 5 times pi over 4. And then in quadrant 4, that pi over 4 reference angle, well, that's going to be pi over 4 times 7. You can even add up the little squares there. And you'll get 7 pi over 4. And had this question been asking for the 4 solutions in one rotation, we're done. But we did want a general solution. So we have to take each of these 4 answers and express them in a similar way to the previous one, only in rads. So let's do it one by one. Theta is equal to pi over 4, the first solution. Well, that answer is going to recur every 360 degrees, or 2 pi rads. So I'm going to write it like this. Theta is equal to pi over 4 plus 2 pi n, where n is an integer. And that tells anybody who's looking at this that that answer keeps recurring every 2 pi rads. And then do the same thing for 3 pi over 4. This would be 3 pi over 4 plus 2 pi n. N is an element of the set of integers. This will also be true for 5 pi over 4, where we get plus 2 pi n, n is an integer. It would also be true for 7 pi over 4. So we have these 4 distinct answers. Now usually that's the end of the story, but in this case there's a curiosity with this 45-degree angle, and it usually happens with 45. If you take a look at this diagram, it's a little bit unclean as far as the 90s and pi over 2's go, but the illustration here is that is showing you that our 4 answers are actually separated by 90 degrees, or pi over 2 rads. And when that happens, or when they're separated by 180 degrees, or pi rads, you can actually simplify that general solution an extra step. Because instead of listing all 4 and going plus 2 pi n, you recognize that they're really just separated by pi over 2. So I take those 4 answers and I start with the smallest one. I take that pi over 4 and I just go plus pi over 2, which is 90 degrees, n, where again n is an integer. And that compensates for all of them. It includes them, because they're only separated by 90 degrees. So you can take those 4 answers and break it down into one. Now that's fairly rare, and it usually happens when you're dealing with 45-degree angles or pi over 4, because they would always be separated by 90. But occasionally it'll show up in other ones too. So that's the exercise. The next lesson will be dealing more with these 45-degree angles, 30 degrees, and 60-degree angles. But it'll be a while before we actually learn any real sort of new mathematics skills. It's important, though, to get really good at this previous type of question. Thank you for your time.